Good evening. Welcome to Mrs. Spencer's Math Lab. While I'm introducing the program, I wish that you would get pencil and paper, and also please do full screen. Hit the little arrows on the side so that you'll be able to see the board and everything better. If you're coming for the first time, I certainly welcome you, and I hope that this will be beneficial to you. And if you're returning, I'm glad you decided to come back. Today, we may be doing a subject that some elementary students may not be able to do, but you as a parent can do it. So get your pencil and paper because they're going to come to this after a while, in about grade 6 or 7, depending on their abilities in math. So let's get ready to do one step today with equations. Before then, I want to say that I hope that you have been practicing adding and subtracting fractions. Remember, it's a skill and you need to practice. So when you leave the program, let's spend some time each day going online, practicing your math skills. So today we're talking about equations. And you said, what is an equation? An equation is a statement that two quantities are equal.
Turn the volume a little bit.
You have a left side, an equal sign, and a right side. So let's suppose I'm the equation. And here I am. This is my left side, my right side, and this is the equation, the equality sign. All right? So now I'm balanced. What happens if I do this? Am I still an equation? Are both sides the same? No. So what would I do to make both sides the same? I would have to bring the other arm down. Am I an equation now? No, because the left side is up and the right side is down. So I would have to do that. The same is true when you're working with numbers. When you're working with numbers, an equation has to have a left side, a right side, and they both have the same value. Let's look at some equations that you have in elementary school. 2 plus 3 equals 5. Is that true? It's true if both sides equal 5. Is 2 plus 3 5? Yes. So this side equals 5, and the right side equals 5. So this is a true equation. So the equation has to be both sides the same value. Both sides have to have the exact same value. All right, today we're going to do one-step algebraic equations. An algebraic equation has a variable in it, like x. We could use any of the alphabets, but most of the time, a lot of times, x will use quite a bit. But I want to be sure that you know that you can use any alphabet. It doesn't always have to be x. X plus 3 equals 5. All right? The left side is x plus 3. The right side is 5. So this is the variable. It's a letter that represents a number. The variable x here represents what number? All right, it represents 2. But when you say solve an equation, you are not just giving me an answer. I did not solve this equation. I just gave you the answer. So today I want to teach you how to solve a one-step equation. Remember, both sides must be equal. And when we say solve an equation, that means we're finding the value of the variable that makes this statement true. As I said, we know that the answer is 2, but we didn't solve it. We just gave the answer. So let's get busy and learn how to solve equations. In preparation for that, I want to do something. I want to talk about the concept that we work with today. To solve an equation, we must do the same operation on both sides of the equation. The same operation on both sides of the equation. That's our concept today. And when we do that, we will find the value of the variable that makes the equation true. So you say, well, what are the operations? The operations are addition, subtraction, multiplication, and division. Those are the operations we're going to work with today. The symbol for addition is the plus sign. The symbol for subtraction is the minus sign. The symbol for multiplication. In equations, we don't use one, but when we're checking it, we can use the times sign or the dot. And for division, we use a line. That line that you see in a fraction is called the dividing line or the division line. And we'll talk about that a little more later. But you always know these are symbols for division. The division radical and the division sign here. So let's get busy and see what this is all about. So what we're going to do is I'm going to do an addition. Let's say we have 6 plus 2. Okay, 6 plus 2 is 8. Okay, suppose I subtract 2. 8 minus 2 is 6. So I got the same thing. So what did I do? I added 2 and subtracted 2. And I got the same thing. Let's do another one. 5 plus 4 minus 4. 5 plus 4 is 9. 9 minus 4 is 5. So again, we have the same thing. So it seems like if I add a number and subtract a number, that same number, that I get the same number that I started with. So that means that when something is added and I subtract that same number, then subtraction is the inverse. What do I mean? It gives you the same number all over again. So when something is added and I subtract that same number, I'm going to get the number I started with. Now I'm going to show you how we're going to use that a little later. All right, so for addition, subtraction is the inverse. In other words, if something is being added, the inverse of adding is subtraction. All right, let's do the subtraction process. All right, suppose I had 4 minus 2 plus 2. All right, 4 minus 2 is 2. And 2 plus this 2 is 4. So I'm right back where I started. Okay? Let's do another one. 7 minus 5 plus 5. 7 minus 5 plus 5 the answer is going to be? I hope you said 7. 7 minus 5 plus 5. Let's see. 7 minus 5 is 2. And 2 plus 5 is 7. So here we are again. When I subtract a number and then add that same number, I get the number I started with. And you're going to see why that's important in a little while. So we say then, subtraction is the inverse of addition, which means that we may add a number, subtract a number, and add that same number, we get the original number back again. You'll see how we're going to apply that in a little while. All right. Let's do the multiplication. Let's see how that works. 2 times 3. All right. 2 times 3. All right. Divided by 3. Okay? So we know that 2 times 3 is 6. And 6 divided by 3 is 2. So here we got the same thing. Let's do another one. 8 plus 8 times 4 divided by 4. 8 times 4 is 32. And 32 divided by 4, if you know your table, is 8. So we got the same thing again. So again, we see the same thing happening with multiplication and division. So if we multiply a number by a number and then divide that product by the same number, we get what we started with. Let's see how all this is going to work for you in a few minutes. All right. Now let's see what happens in division. All right. 6 divided by 2 times 2. 6 divided by 2 is 3. And 3 times 2 is, you guessed it, 6. So we have the same thing we started with, doing those two operations. Let's do another one of those. 10 divided by 5, and then multiplied by 5. 10 divided by 5 is 2. And 2 times 5 is, you guessed it, 10. So again, we see division works the same way as multiplication. So to sum it up, subtraction is the inverse of addition, and addition is the inverse of subtraction. So we can put that in one sentence together and say, addition and subtraction are inverse operations. And we know what that means now. And we can do the same thing for multiplication and division. Multiplication and division are inverse operations. Right? So I'm going to put some up here, and I'm going to let you work with them for a few minutes. And what I want you to do, I want you to just look at it and tell me the answer. See if you can do it. See if you can do it just from what I have told you. I'm going to put big numbers so you won't have time to do them. Or you should be able to write that answer for me, okay? Okay. Okay, and okay. All right, now, if you can look at those and tell me immediately what the answer is, you have learned what I have told you about inverse operations. You have learned it. So I would like for you to let me know if you were able to just look at this and write the answer, because that is what I want you to be able to do. You don't even have to multiply it out. Because you know, if I add 4 to 42 and then subtract 4, I'm going to get 42. If I subtract 14 from 68 and then add 68, I'm going to get 68. If I multiply 9 by 3, 3 by 9, and then divide by 9, I'm going to get 3. If I, all right, if I didn't finish this. All right, if I multiply 5 by 8 and then divide by 8, I'm going to get 5. If I divide 26 by 2 and multiply by 2, I'm going to get 26. And if I divide 98 by 2 and then multiply by 2, I'm going to get 98. Now, you should have had to work that out to get the answer. Why? Because you know that adding 4 and subtracting 4 would give you the original number because they're inverse operations. Subtracting 14 and adding 14 would give you the original number. All right? Multiplying by 9 and then dividing by 9 would give you the number you started with. Multiplying by 8 and dividing by 8 will give you 5 all over again. And so on. I hope that you were able to do that without trying to get your calculators out. And I'm sure some of you did reach for them and trying to do it. Inverse operations have that effect on it. So today we're just going to work with these 4. There is another one that I'm going to work with on next week. All right, so I'm going to see how many of you can answer this question. Remember, inverse operations give you that same number you started with or same quantity you started with. So just for fun, I'm going to put this up here. X, this is a variable, minus 2 plus 2 equals what? Y plus 2 plus 8 minus 8 equals what? 2 times y divided by 2 equals what? And y divided by 2 and then multiplied by 2 equals what? Let's see if you can transfer what we just said. We have just said that addition is the inverse operation of subtraction. So if we added the same thing and then subtract it out, we're getting the same thing we started with. Subtraction and addition do the same thing. Multiplication and division do the same thing. And division and multiplication do the same. All right? So what is the answer for number 1? I started out with x. I'm subtracting 2 and adding 2. So what is my answer? I hope you said 2. Don't say, I don't know what X is. You don't have to. Whatever is first, if I subtract from it and then add the same number to it, I'm going to get that number. So this time it's X. So you should be able now to do the other. You should be able now to do the other 3. Let's see if you can do the other 3.
X. Yes, an X.
Oh, I'm sorry. I said X and wrote 2. My husband had to tell me I'm talking and writing, but I underlined the X, so okay. Now we together? Okay, so you should be able now to do the other 3. We're adding 8 and subtracting 8. We're multiplying by 2 and dividing by 2. We're dividing by 2 and we're multiplying by 2. All right, so if you have the principle that I have told you, then we started out with Y. We added 8 and subtracted 8. So the answer is Y. Okay? Here we started out with Y again, multiplied it by 2, and divided it by 2. So the answer is Y. Here we start with Y again in this one, and we're dividing by 2 and then multiplying by 2. So the answer is Y. Y it's just a variable and it represents a number. But right now, we don't have a number in its place, so we use it to represent a number. All right, so let's go back over what we said. The operations are addition, subtraction, multiplication, and division. And what we find is that addition and subtraction are inverse operations. So one will actually undo the other, because that's what happened. I subtracted 2, added 2, and I started right back where we started. I added 8 and subtracted 8. So we were right back where we started. And the same is true with multiplication and division. So let's see how all that works with an equation. So I'm going to put a little equation up here. The same x plus 2 equals 5. Now, in order to solve this, I know everybody knows already, oh, I can do that. The answer is 3. Yes. But just giving the answer has not solved the equation. All right? So remember now, we said that the same operation had to be done on both sides of the equation. So let's see what the process is for solving this equation. First of all, we're going to look at the variable and see what operation is being done to the variable. Here we're adding 2. Adding 2. All right? What is the inverse operation for adding 2? I hope you said subtract 2. All right? So this is the inverse operation. So we have to perform that on both sides. So we're going to say subtract 2 and subtract 2. We already know that if we add something and subtract the same something, we're going to get what we started with. So the answer is X on that side. And on this side, 5 minus 2 is 3. So we have solved an equation. And the third step, which I did not write up here, but I'm going to put it, always check your answer. Check your answer. So, to check it, I'm going to say X plus 2 equals 5. And we found x is 3, so now I'm going to put 3 in place of x. I know what x is now. 3 plus 2 equals 5. So this equation has been solved correctly. Isn't that easy? Isn't that easy? All right, I'm going to put one up here for you to do. X plus 4 equals 9. And I'm going to pause a minute and let you do it. Look at the process. First, see what is being done to the variable. And the variable is the alphabet letter that stands for a number. Then, see what the inverse operation is. What's being done to the variable, then do the inverse operation on both sides. All right, so I'm going to pause a minute. Now, I know you already know the answer, but I want you to solve the equation. Just giving me the answer is not the thing. Solving the equation is going through this process on both sides of the equation. All right, what did you do on both sides of the equation? The inverse of adding 4 to x is subtracting 4. And I'll keep the equal sign on every line. Then you don't get it confused. Okay? So, if I add 4 to something and subtract 4, I end up with that. X plus 4 minus 4 is x. And 9 minus 4 is 5. And if we check that and we put 5 in place of x, 5 plus 4 is 9. 9 equals 9. All right, so now let's do a subtraction. X minus 4 equals 9. Pause a minute and let you put your thinking cap on. Remember the process. Keep looking at it until you don't have to look at it. See what operation is being done to the variable and perform the inverse operation on both sides of the equation, then check. I know you already know what the answer is, but that's not solving the equation. Solving the equation is a process, and that's one step today, and that's just doing the inverse operation on both sides of the equation. All right. The operation being done on the variable is subtracting 4. You got that? Just shoot me some, I got it, so that I know you're with me. All right, what is the inverse of adding 4? And this time I'm going to do it horizontally because many times teachers do it that way. X minus 4. The inverse of subtracting 4 is adding 4 equals 9. And I must also add 4. All right? So we know we've done the inverse here, and the answer here is x. And 9 plus 4 is 13. 9 plus 4 is 13. Let's check it. X minus 4 equals 9. 13 minus 4 equals 9. 13 minus 4 is 9. So both sides of the equation equal 9. So we have solved it correctly. Now, you may have a child that's not yet ready to do this, but one day you're going to need to help them. So please have your pencil and paper and review this if you have forgotten it. And So you can use some of the methods that I have used to try to make it easier. All right, let's try some others. Let's try. We've done subtraction and we've done addition. This is easy, isn't it? Nothing to it. All right, this 2x equals 14. Now, 2x in algebra, we often do not write a time sign or the time sign or the dot. We just say 2x. That means 2 times x. That means 2 times x. So I'm going to put it over here so you'll remember that right now. So we're multiplying x by 2. All right? So we've already decided what is done to the variable. It's being multiplied by 2. All right? And the inverse of multiplying by 2 is dividing by 2. So I'm going to have 2x. And I told you this little fraction line meant divide. All right, and we read it down like this. All right, so this sounds like 2x, 2 times x, divided by 2. Right? And then on the other side, I have to do the same thing. And we come back with some more of these so you get used to the way we do this. Equals 14 divided by 2. And of course, these 2's cancel out, but we know that if we multiply something and then divide it, we're going to get x. And 14 divided by 2 is 7. Let's check it and see if it's correct. Go back to the original equation. 2 times 7 equals 14. 14 on this side balances out 14 on that side. It's just like doing a balance, like a scale. All right? If you have questions, shoot them off for me so that we can handle them as we go. All right, let's try another multiplication. Read that equation with the operations. 4 times x equals 12. Say it with me. 4 times x equals 12. All right? See if you can do that. See what the operation is that is being done to the variable. Then do the inverse of that operation on both sides of the equation. And check. Be certain. One thing in algebra, you can always know if you're right or not if you check your work. Usually the student that does this quickly, runs up and gives the teacher the paper, has not checked their work. But you can always and should always take time to check your work to be sure that you have done it properly. All right, 4 times x equals 12. So x is being multiplied by 4. The inverse of multiplying by 4 is dividing by 4. And that's what this line means. It's the same line you use with fractions. And we call it the dividing line, but it's more than that. It's really a division line as well. So we have to balance this out. So we have to divide 12 by 4 as the same. So if you want to do this on the side, 4 into 12, and that answer is what? 3. Or if you want to do your 4 tables and say 4 plus 4 is 8, plus 4 is 12. All right, so you have 3 4s. All right, whichever way you do it, whatever level you're on. All right, so the answer here is X, and this is 3. 3 4s in 12. Checking it, 4X equals 12. 4 times 3 equals 12. Times 3 is 12. So both sides say the same thing. So we know that we have solved the problem correctly. All right, so let's back up. When something is being added to the variable, we subtract that number from both sides. And we get our answers. When something is being subtracted from the variable, we add something, that same number, to both sides. And then we find the value of the variable that way. When something's multiplied, a variable is multiplied by a number, we divide both sides of the equation by that same number, and we have solved the equation. So let's see if the same thing happens with division. All right, let's say X divided by 4. So that is X divided by 4 equals 3. Make it easy. What operation is being done to the variable? I hope you now know that this means division. Okay? What is the inverse operation of division? Multiplication. Solve that equation for me. So this is how it looks. 4 times, and that's where we use a little dot. X over 4. You don't want to use the times sign because what's going to happen, you're going to get that mixed up with the X. So I suggest when you're using X that you don't use the times sign. All right, we're multiplying by 4, so this is 3 times 4. And this little dot means multiplication. I'm making it really large, but it's not a big ball. It's really a dot, but I want you to see it. So I know when I multiply X by a number and divide it by that same number, the answer is X. And 3 times 4 is 12. All right, so let's check. Okay, X over divided by 4. We say X over 4. I want to do the operations so that you remember that's division. All right, so in place of X now, I can write 12. 12 divided by 4 equals 3. Does it? Yes, because 3 times 4 is 12. So 3 on this side is the same as 3 on that side. So we have solved an equation. Questions? Shoot the questions if you have some. I think this is easy enough. We can solve 4 types of equations so far. So we have addition, subtraction, multiplication, and division in one step. All right, let's do one more of these. X, we'll use Y. We wear X out. Y divided by 2 equals 24. Get some bigger numbers now. You're getting used to this now. All right, I'm waiting a moment for you to solve it. Keep looking at the process until you get it in your brain. Then when you don't have to look at it anymore, you can just go right to the problem and solve it. And I'm hoping that youngsters will not use calculators. Parents teach them how to multiply teach them their tables. That's why they do poorly on tests sometimes, because it takes them so long without the calculator. And sometimes the teachers do not allow them to use calculators on their tests. So you need to not let them use them at home for every little thing. When it's very large numbers, teachers do allow them to use it to save time in the process. But you don't want your child, when you say 2 times 3, to have to grab a calculator. Work with them on their tables. All right, let's see what you did. What operation is being done to the variable? This says y divided by 2. So this is division. All right, what is the inverse operation of dividing by 2? Multiplying by 2. So we have 2 times y divided by 2 equals, and we have to do the same thing, 2 times 24. All right? So we on this side, we're going to get y because we did the inverse operations. We don't have to worry with the numbers if we know the inverse operations. 2 times 24. 2 times 4 is 8. 2 times 2 is 4. So y equals 48 to make this equation true. Let's check it. Y divided by 2 equals 24. We know now that y equals 48. 48 divided by 2 equals 24. This is our scratch paper over here. Let's divide it. If you don't know, 48 divided by 2. 2 will go into 4 2 times. 2 times 2 is 4. Subtract, no remainder. Bring down to 8. 2 will go into 8 4 times. 4 times 2 is 8. 8 minus 8 is 0. So the answer is 24. So this is solved correctly. 24 equals 24. All right. So far then we've learned how to do one-step equations by doing inverse operation on both sides of the equation. If you have questions, shoot them to me. Next week we're going to go over this again, and we're also going to add some other things to it. Remember, inverse operations. If I walk up 2 steps and back 2 steps, where am I? Right where I started. And that's what we mean by inverse. So if I start out with an x and divide it by a number, and then multiply by that same number, I'm going to get x. And that's what you're trying to do when you solve an equation. You're trying to find the value of the variable by performing the inverse operation on both sides. I'm going to put a few up here, and we may not go over all of them, but I'm going to put one of each kind. I'm going to pause, and I'm going to see if you can do them. And I'm going to use easy numbers so that you can show me that you understand. All right? For the first one, let's do y plus 10 equals 12. See, I give you ones that you know the answer to, but it's not the answer I'm looking at. I'm looking at doing the inverse operation on both sides. All right? Number 2, I'm going to do x minus 3 equals 7. For number 3, I'm going to do 3x equals 6. Very easy problems. You know the answers to these. But that's not what I'm after. I'm after you doing this process. One step, that's solving an equation. All right? And 14 divided by, I don't want that one. Okay, x, I'll use something else. I'll use m. M divided by 3 equals 21. All right, let's work those. And I'm going to pause for a moment. I hope that you will remember. It's not about memorizing. It's about practicing it enough so that it becomes automatic. And every time you're doing these problems, go through the process. Read the process if you need to. But after a while, if you practice enough, you won't have to read the process because you will understand why you're doing it. I never want to hear you saying, I'm putting this on both sides of the equation. Putting is not a mathematical operation. We're not putting something on both sides. We're either adding, subtracting, multiplying, or dividing. So let's get mathematical language as we do these problems. Do not get in your mind we're putting something on both sides. We're operating on both sides. Adding, subtracting, multiplying, or dividing. If you have done all of these equations, let me know. It's almost time to quit, but I want to be sure that you can do it. And go online and put up there one-step equations and practice them. And next week, we're going to review this, and we're going to add something else to it. But this is a basic way we solve one-step equations. There's one type that I have not yet done. That's with the fractions. And I'm going to do that next week. So don't just, and I tell my students, when you write down the equation, don't just start pushing a pencil. Remember, you're the brain. The pencil is a dummy. It does only what you tell it to do. So when you write something down, or when it's something you're taking a test and the equation is already written, don't just start in doing something. Think about what it is that you're trying to accomplish and how do I accomplish that. So let's remember solving one-step equations so far, the ones we've done today and the one we'll do next week, is performing the inverse operation that is done on the variable. And the variables are these alphabets. One adult told me we were talking, and she said I never could understand what to do with those X's. So she never understood what a variable was. So I'm sure she never understood. This variable just represents a number that we have to find. And we find it not by saying, oh, I know the answer to that. That's 2. Sure it is. But you gave me an answer. But you have not solved this equation unless you subtracted 10 from both sides. And I hope you did that. You have not solved this equation unless you add 3 to both sides. You have not solved this equation unless you divide the 3 on both sides. And you have not solved this equation unless you multiply 3 on both sides. So remember, we're solving one-step equations. Then we have one variable. All right, and later on, we're going to do equations that have more steps. And some, when we get farther along the line, they have more variables. But that's a long way off. We'll do that much later. You want to be sure you have the fundamentals, ideas of how to solve an equation. Solve an equation is doing the inverse operation on both sides of the equation. And we know now what the inverse operations are. For addition, it's subtraction. For subtraction, It's addition. So they're inverse operations. Addition and subtraction are inverse operations. For multiplication, it's division. For division, it's multiplication. So multiplication and division are inverse operations. That's easy enough. So now you can say, even youngsters who have not had this online can say, I know how to do an equation. You can learn it ahead of time. So when you get to it, you're already doing it and you'll be ahead of the class. So again, it's been a pleasure to work with you. I pray that you have gained something today, that you know how to do one-step equations, and that you will practice this week. I'll see you next Tuesday for Tuesday tutoring.